Here's our work for adding and subtracting integers. And remember, these videos are your ticket to take the intervention tests. This happens to be Concept 2.1, adding and subtracting integers. You'll find videos earlier for absolute value, and you'll also find some later videos for multiplying and dividing integers when you're ready for those tests. So we're going to use the tile method. So on problem number 1, we're asked to add 6 and negative 3. So we have 6. So let's put in 6 positive tiles. And we're adding negative 3. We're adding 3 negative tiles. That creates 3 zero pairs. If you look over on this test, right over here, they talk about the idea of a zero pair. It's where a positive and a negative cancel each other out. What's left? The 3 positives are left. So we know, let me actually move my work down so I can write the answer where the answer goes. So here's what we know. We know that there were 3 zero pairs. So I'm going to write those down. 3 zero pairs. Those 3 canceled out. And what was left were these 3 positives. So our answer is positive 3. On our second problem, we have negative 3 take away negative 1. There are several ways you could handle this. You might look at saying, here are 3 negatives, and I'm asked to take one of them away. Let me change that color so it stands out. I'm asked to take one of them away. I'm taking one away. That's going to leave me with negative 2. That's one way to solve this problem. That works well because we have more negatives here than we have here. Let me show you a different method that can work for all of these kind of problems. And remember, I'm going to erase this now. You can always rewind the video to look at this. So I'm going to get rid of that for a minute. Here's a way that always works, and that way is to change subtraction to addition. So instead of negative 3 take away 1, negative 1, we're going to have negative 3 plus positive 1. We are going to add the opposite. So then we can go ahead and use our tile idea. Here are my 3 negatives, 1, 2, 3. Here is a positive. Here's 1 zero pair. And just like last time, what's left over is negative 2. Doesn't matter which way you solve it, you need to get negative 2 for an answer. All right, now let's move down to these. And these are integer logic statements. So the first statement is, we are taking a number, an unknown number. We're adding negative 3, and we're getting a positive. Well, this is negative 3, which means we have to cancel all those negatives out and have positives left. We need a number that is at least 4, greater than or equal to 4, if we're staying with integers. If we weren't using integers, anything greater than 3. But let's do integers, greater than or equal to 4. If we had that, we would have, here's why 4 works, because we would have 4 positives, and we would have 3 negatives, which would give us 3 zero pairs, and we'd have a positive left over. Letter B, 8.4 plus something to get a negative. Well, we're starting with a positive. We're trying to get to a negative. We need to have more negatives than 8.4. So we need a number that is less than or equal to 9 negatives. So less than or equal to negative 9. Let me rewrite that because it's kind of crammed in the box there. So let me write it again so it's easier to see. So less than or equal to negative 9. If we had 9 negatives, they would cancel all of those positives out, and they'd leave some negatives left over. How about negative 2 1/5 minus something to get a positive? Well, that's just like letter A. We're starting with a negative. We're trying to get to a positive, which means we need to have more than that. We need to have at least 3. If we had 3, that would cancel all those out and leave some positives. So your answer should have been any number greater than or equal to 3. You could have had 3, You could have had 4. You could have had 5, 6, anything going up there. Going back to A, greater than 4, you could have had 4, 5, 6, anything more positive. On B, less than -9, you could have had -9 or numbers smaller, -10, -11, -12, things smaller than that. Finally, letter D, 10 minus something equals 0. This is a question, and it was interesting to watch this when we took these on tests, because people wanted to keep putting -10, like they had to do the opposite. If I asked a 4th grader, 10 minus what makes 0, they would say 10, because they haven't learned enough other stuff to be confused. Remember, if it says, what do you have to add, if the question had been 10 plus what equals 0, then you would need to add the opposite. Then the box would have to have -10. But since it was 10 minus what made 0, the answer is 10. Okay, there's another set of problems below. If you feel like you need to take a minute to rework those, go ahead and pause the video. You're in control. And then scroll down to the bottom, and we'll watch the rest together. All right, here we are. First problem, -3 plus 7. So we have 3 negatives. 1, 2, 3 negatives. We have 7 positives. 1, 2, 3, 4, 5, 6, and 7 positives. That gives us 1, 2, 3 0 pairs. And since that gives us 3 0 pairs, we have 4 left over. We have these 4 left, and our answer is +4. 5, take away 8. Well, first off, you know your answer is going to be negative something, because you're taking away more than you have. On this, I would strongly recommend you change it to an addition problem. 5 plus -8. There are 5 positives. 1, 2, 3, 4, and 5. There are 8 negatives. 1, 2, 3, 4, 5. I bet many of you are already saying, oh, 5 0 pairs. Yep. 6, 7, and 8. And yes, there are the 5 0 pairs. So you've got 5 0 pairs. We have 3 negatives left. These 3 negatives are left. And that's our answer, -3. Down in our logic problems, the first logic problem looks pretty familiar. You have a negative plus something to make a positive. You have to have more than the -1.4. So you have to have something, an integer, at least 2 positives or greater. Could be 2, 3, 4, 5, any of those. For 9, +9, plus something to get a negative, well, we need to have more negatives than that positive. So we need to have, for an integer, we need to have at least 10 negatives. We could have -10, we could have -11, we could have -12. Any of those would give us enough 0 pairs to cancel all the positives out and still have a negative number left over. Letter C, something minus this to be a negative. Well, let's go back here to this top part. 5 minus 8 gave us a negative. What else would give us a negative? Well, 2 minus 3 would give us a negative, -1. 7 minus 10 would give us -3. 10 minus 19 would give us -9. Notice every time to get a negative, your number in the front has to be smaller than the amount you're taking away. So we need something smaller than 3 1/4, which means we need a value that is less than, for integers now, less than or equal to 3. If you took it away from 3, or 2, or 1, or 0, or -1, actually any negative number, you'd have the right answer. And letter D, negative 6 plus something to get 0. This is that opposite one, so negative 6 plus positive 6 makes 0. You'd have 6 negatives, 1, 2, 3, 4, 5, and 6. You'd have 6 positives, and what would be left when you canceled all of those with 0 pairs, with the 6 0 pairs, there would be nothing left. There would be 0 left. All right, once again, as soon as you're ready, as soon as you've watched this and you've checked your work and you understand it, go to Mr. Christman or Mr. Willmarth and say, I'm ready for a test. But don't do that till you're really ready. If you need a little more help, either ask your teacher, or you can ask one of your friends who understands this concept of adding and subtracting integers. Make sure that when you walk in for that intervention test, you are ready to be super successful.